Okay guys, so this is a little practice on learning target 8 and 9, for those of you that need it. Hope you're enjoying my house, because I'm making this on a Friday, so yeah, that's how much I like you guys. Alright, so I'm just going to do a couple problems, so that way we can practice this. So I'd write this down, study it for your test. Alright, I'm on my pen. So the first problem I'm going to write, we are going to have a 2n squared equals negative 144. So if I want to find my n, I need to get rid of this 2. It's the same thing as if this wasn't a squared. So I still need to get rid of that 2 first. So now I'm going to have n squared equals negative 2 goes into 14, 72. Now I need to get my n, so I have to take the square root of both sides. But here's my problem. Here's a negative under the square root, and I always told you guys we can't take a negative under the square root. So guess what? This problem is no solution because we cannot have a negative under our square root. If that was a positive, we could do it. And then we would just have to simplify the square root of 72. It's not a perfect square, but we can simplify. New problem. So m squared plus 7 equals 88. We minus 7 from both sides. I'm doing this just like normal, where we get rid of our constant terms. 88 minus 7 is 81. Now I square both sides. It's a positive. I can do this. So now I'm going to have m equals a plus or minus 9. Because 9 times 9 is 81, and negative 9 times negative 9 is 81. So when you get here, this is the only time when you do something like this that it should be plus or minus. If you're squaring something, the answer is a positive. That's just what it is. You don't have to put plus or minus. But if they're taking the square root, that's when you use both. Alrighty. Oops, I just did that one. Negative 5x squared equals negative 500. Divide by negative 5. Cancel. Positive 100. Take the square root of both sides. X is going to equal plus or minus 10. One last one. I have to add my 1. Get rid of my constant term first. Now I get rid of my coefficient. Then I square root both sides. So in all of these problems, I can check my answers. So like right here, let's look at this one real fast. If I plug in 2 or negative 2, it should still work. So 7 times 2 squared minus 1 equals 27. Exponents first because of PEMDAS. 7 times 4 minus 1. Multiplication next. 28 minus 1 is 27. I'm going to change my color real fast. Now if I were to do it with a negative, 7 times negative 2 squared minus 1. Negative 2 times negative 2 is still 4. And now that brings me right to this step. I'm going to also get 27. So you can still check your work on these. Okay. Some more types of problems. Okay, so things that I was seeing in class. Some of you are doing this when you were squaring. This is not how we square this term. If you have a squared outside of parentheses, you have to, or outside of a polynomial, you have to FOIL. So this would be very, 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 very wrong. I don't like that. If you were going to FOIL, you would get this. But now we have this x, this x. We're going to have to move this 16 over here, and I'm going to get something where I would have to, we haven't learned it yet, so I don't want you to do this. If you get this far, where you have an x squared and an x, you know you've done something wrong because we don't want a bunch of x's. We're trying to just find x. So the smartest decision is to square root both sides. So that's going to leave me with x plus 3 on this side. Remember, when I take the square root of something, it's always a plus or minus number. So now I have two options for an answer. I have the positive one and the negative one. So now when I subtract 3, I can have x equals 1. And then when I subtract 3, I can have x equals negative 7. So let's think of this. What's negative 7 plus 3? Negative 7 plus 3 is a negative 4. Negative 4 times negative 4 is a positive 16. 3 plus 1 is 4. 4 times 4 is 16. That's how I know that I have the right answer. Let's do another one like that. So the first thing I'm going to do, and I'll do it in a different color so you can see the original problem. I see a square. I don't want to FOIL because it's set equal to something. Squaring does not mean x squared minus 4. That's not how we do this. You would have to FOIL, but I don't want to FOIL because that's going to give me an x squared and an x term, and I just want x. So I'm going to take the square root of both sides. When I do that, I'm left on this side with x minus 2. The square root of 64 is plus or minus 8. So now I have two options. I have x minus 2 equals 8. That's my positive one. And I have x minus 2 equals negative 8. That's my negative answer. I have two answers here. I have to keep going. I can add 2. And I can add 2. So over here, I would have x equal to 10. Over here, you can sing your little song. They're different signs, so I'm going to subtract, keep the sign of my bigger number. So I have two possible answers with this problem. All right. More problems. Yay. Now if we had something like this. So again, we're still solving for this x. A lot of you just tried squaring right off the bat. Let's not do that. We still want to move this number. Now I can square it. Since I'm just squaring something, I do not put plus or minus. Do not put plus or minus. Let's do another one. So 3 plus the square root of x equals 8. I have to move this 3. To do that, I subtract it. I still have square root of x equals 5. Square both sides. X equals a positive 25. And one more. Square root of x minus 4 equals 5. Have to add my 4. So I have my square root of x equals 9. Square both sides now. I get a positive 81. All right, let's work on just simplifying these square roots. So remember, I'm thinking of things that multiply to give me 12. So 1 times 12, 2 times 6, 3 times 4, and I'm done. That's not really 4. There we go. Now, if any of these are a perfect square, and by a perfect square I mean like this. 2 squared is 4. 3 squared is 9. 4 squared is 16. Anything that would be in this column, and it keeps going down, right? We have 5, 6, whatever they are. These are my perfect squares. So if any of these numbers are ever over here where they multiply, that's the one I want to use. So I see a 4. Here's my 4. So now I want to rewrite this as square root of 3 times the square root of 4. Well, guess what? What's the square root of 4? 2. So that leaves me with 2 root 3. What if I had 4 root 8? 8 times 1, 4 times 2. Here we go. So now this is 4 times the square root of 4 times the square root of 2. Square root of 4 is 2. So now I have 4 times 2 times the square root of 2. 4 times 2 is 8. and I still have my root 2. Square root of 27. So I'm going to just do this without making my little list now of these things. I know that's a 9 times a 3. This is going to give me 3 root 3. And one more where there's a number out front. I'm going to put that over here. I'm going to give you, separate it. 2 root 32. So I know that this is going to be, so right off my head, the only thing I can think of is 4 times 8. That's the only thing I can think of. And I know the square root of 4 is 2. So then I get 4 root 8. But hold on. 8 I know is 4 times 2. So now I have 4 times 2 times root of 2. So then I have 8 root 2. Okay? So you just make sure you keep going. Keep going. All right, adding 2 root 5 plus root 5. We can add these because they have the same number underneath. It's kind of like combining like terms. You can only combine x's together and y's together. Well, we can only combine if they both have the same number underneath. Or subtract, so you can do anything. Remember, when there's nothing written in front of here, we can assume that it's a 1. So 2 root 5 plus 1 root 5 would be 3 root 5. You can subtract. 3 minus 2 is 1 root 7, which is the same as just root 7. So if I gave you this, oops, whoop, that's supposed to be a 3. Okay, so now I'm going to look for the things I have in common. I have a root 13 here, and I have a root 13 here. I'm going to keep that plus sign with it. So then root 13 plus 5 root 13 is going to give me 6 root 13. Now I see here I have a positive 12 root 3 and I have a minus or a negative 7 root 3. So 12 minus 7 is 5, and I still have my root 3. And that would be my final answer. Okay. Let's look at multiplying. Root 6 times root 5. Whatever's underneath, you just multiply them together. Put them under the same thing. And then we think, can I simplify this anymore? Let's think. I have 10 times 3, 6 times 5, 2 times 15. None of those work. I'm done. That's my final answer. What else do I have here? Square root of 8 times square root of 3. So right away, if you wanted to, you can do this, 8 times 3, which equals, 8 times 3 is 24. But then I can think, oh wait, that's also square root of 4 times the square root of 6, which is 2 root 6. Or you could have done it right here. Right? Square root of 8 is square root of 4 times the square root of 2, which would give me 2 root 2, times root 3, would still give me my 2 times my 3 is my 6, 2 root 6. So you can either multiply it right away, or you can simplify and then multiply. Either way, you'll get the same answer. So let's look at square root of 12 times the square root of 5. First way I'm going to do it is where I multiply them right away. So I do 12 times 5, which equals the square root of 60. When I think of that, I know that that's the same as 10. Oh, that's not what I wanted. Might be. When I look at that, sorry, I was doing 10 and I'm thinking 110. Doesn't work. Okay. I'm thinking 4 times, can I fit this? Okay, no. Hold on, I'm going to erase this. I'm not going to erase it. I'm going to write it down here. Times 15. There we go. Like this gives me 2 root 15. Could do the same thing here now. You get 4 times 3, which is 4 times 3, which is 2 root 3. 2 root 3 times 5, or 5. I still have my 2 out front. 3 times 5, 2 root 15. OMG, same answer. Division. So, first thing you do, if they can be divided by each other, yep, 50 can be divided by 10. I just take it and I put it all under 1. And then I do that, and that gives me 5. And then I can do 70 over 2. I can put that all over 1 because 70 can be divided by 2. And I get that. And then I have this, 44 all over, oops, I don't want this to be 44. I want this to be 48. Over 4, which is going to be 48 over 4, which is going to give me the square root of 12. Here's where I need to look. I can break this down more. 4 times 3, 2 root 3. So don't forget to keep trying to simplify. These are already done. All right, and the last thing. When we distribute, parentheses. So we have to distribute. This right here is one term, and this right here is one term. This would be like 5x. It's one term. So when I take this times this, I have square root of 5 times square root of 5. And then I take my square root of 5 and I times it by this, which is going to give me square root of 5 times 2 root 3. Square root of 5 times square root of 5, I just put them over under here. That gives me square root of 25. Square root of 25, hey, guess what? That's 5. When I multiply here, if there was a number out front, I'd multiply them, but it's not. So this is kind of like 2 times my 1. So I'm still going to have 2, multiply what's underneath. So this would be 2 root 15. So my answer is this. I cannot combine these. I do not multiply this root 5 times 2 and get a 10 out here, or a root 10. You can only multiply underneath what's underneath. So let's try another one. Sorry, I had to find it. So I have this, and I have this. So root 3 times root 2 is going to give me root 6. Root 3 times root 3 is going to give me root 9. Up. Root 9 is actually 3. So now I have 7 times 3, which is 21. But normally we write it like this. So you're just doing the same thing. And we'll do one last one, a little harder. Root 2 times 3 root 2 minus 4 times root 3. So I'm taking this and multiplying it by there. This 3 is staying there. I now have 2 times 2, which is 4. I now have a minus. This 4 is staying here. My 2 times my 3 is a 6. Root 4 can be broken down into 2. 3 times 2 is 6. Minus 4 root 6, and I'm done. Alrighty, hope that helped a little bit. And remember, if you want to keep studying, go to Graph's part of the website, click on his name, scroll to the bottom of his videos, and there's a bunch of different things for you to study there, including the station work that we did today in class.